In this question, we have a number trick. Choose any number, add 3, double it, add 4, divide it by 2, take away the number you started with. And each time the trick is attempted, she ends up with 5. So her proof does not prove that though. So there's an error in her proof. So she starts with any number, and at the end she should end up with 5. And she has n plus 5. So we can take a look at what the error was in this. So first of all, we can try a couple of numbers just to see if we agree with what she started with. So with the number 1, you start with 1, you add 3, gives you 4, double it gives you 8, add 4 gives you 12, divide by 2 gives you 6, and then take away the number you started with, which was 1, gives you 5. Now we'll do the same thing again with the number 10. We start with 10, add 3 gives us 13, double it gives us 26, add 4 is 30, divide by 2 is 15, subtract the original number, which was 10, and we end up with 5. So we end up with 5 with both of these. So we can see a pattern, but this is not a proof. This only supports that the trick will end up at 5 every time. So what is the proof? So when we look at the proof of this, we start with n. N can represent any number. And then we add 3 to n, just like she was doing in her proof. And then we double the quantity. So we double n plus 3 to give us 2n plus 6. Again, this is valid. Now our next step is to add 4. So adding 4 to 6 is just 10. The next step is to divide both sides by 2, or divide everything by 2. Now when you divide it by 2, at this step, we have a mistake here, because when we divide this by 2, we should get n plus 5. So that's the mistake, and if we correct that mistake, we'll have n plus 5, and then when we subtract the original, we'll end up with the n's canceling out, and 5 equals 5. So 5 will work for every time. So now this is a proper proof. We've corrected the mistake.